welcome back to QST. This is another video of chemistry for the week 7 quiz. Which of the following mixtures can be separated using filtration? Filtration is for insoluble solid and liquid. So sand and water is the only right one. Okay. Which of the following is an ion? An ion is a molecule or atom that carries a charge. So it can be positive or negative. And the right answers are molecule carrying a charge and an atom carrying a charge. What is a saturated solution? A solution, okay, so a saturated solution is like where there is like a maximum amount of solute concentrated. So the max, like it's at its maximum solution. The solute is it's like maximum dissolved. A solution in which the maximum amount of solute is dissolved in a fixed amount of a solvent at a certain temperature. Memorize this one. The separation technique used to separate two solids based on their difference in solubility. It's kind of evident it's selective solubility. There's also memorization. A beaker containing an ethanol solution should never be heated using a Bunsen burner. Why? Because ethanol is highly flammable. So keeping it directly over the flame is dangerous. It's not safe. That's why you should use a water bath or electric heater. Sublimation. A substance sublimes when processed directly from the solid to the gas state upon heating. Okay, so it does not pass to the liquid state. It's straight from solid to gas. That is what we call sublimation. Question 7. Check the mixture that can be separated by distillation. Distillation is for soluble solid and liquid. So that is like when you use distillation when you want both the substances. Like you could just use crystallization for salt and water, but then that'll get rid of the water. Distillation, you get both of the substances. And you can also use fractional distillation, which is for close boiling points, liquids with close boiling points. Here the answers are pure water from seawater. That way you can reduce the water from the seawater, and water from sugar water solution. You can get the water, just the water from the sugar water. Okay, a mixture of water and ethanol can be separated by, like I said, ethanol and water have close boiling points, so they can be separated by fractional distillation. Which of the following techniques is used to separate black ink into components? Black ink into components. This one is paper chromatography, which is what is shown in the fourth picture over here. This one. You need to memorize this one. You need to understand as well. Okay, it's what you do for separating ink, black ink. Okay, select the picture that represents the technique used to separate the components of a solution of salt and water. Like I said, you can use distillation when you want both the substances. You want both of them, so you can use distillation. Crystallization is correct, but then you need both the substances. You need to separate them, so you can use distillation. It's for soluble solid and liquid. Which of the following passes the fractionating column? It's just memorization. This is the fractionating column. And what does it do? It's a long vertical tube containing obstacles and cooled only by air. That's the fractionating column. Copper sulfate can be separated from its solution by crystallization. Yes, so copper sulfate is a salt. Salt is separated using crystallization. Okay, now we get into the part. Okay, CaCO2, which is an ionic compound, dissolves in water to form a solution that conducts electricity. Yes, ionic compounds, when dissolved in water, they conduct electricity. Sugar dissolves in water to form a solution that does not conduct electricity. So sugar in water, it doesn't conduct electricity. It is a non-metal. It doesn't conduct electricity. This is because unlike sugar, when CaCO2 dissolves in water, it forms charged ions that allow the electric current to flow. That is what ionic compounds do. They form charged ions that allow the electric current to flow when dissolved in water. Molar concentration. So we have a rule which is N is equal to CV. We have the volume is 1. We have the moles is 0.5. So 0.5 over 1 is the concentration. We get 0.5. Okay. How many moles of a sodium carbonate should be dissolved in 0.1 decimeter cube of water to make a 0.5 molar concentration solution of that salt? Okay, so we have the volume and we have the molar concentration. N is equal to CV. 0.5 times 0.1 gives you 0.05. Okay, go down. Okay, we need to find the volume. 0.1 mole, 0.2 molar concentration. So 0.1 is equal to 0.2 times, we need to find the volume. So 0.1 over 0.2 gives us 0.5. Last one, the student wants to prepare 100 centimeter cube. Okay, 100 centimeter cube, we need to make a decimeter cube. That is a standard unit for volume, decimeter cube or liter. So you have to divide by 1000. So the volume is 0.1. Molar concentration is 0.1 as well. Find the mass. Okay, mass. So we know that N is equal to CV. Yeah. So 0.1 times 0.1 is the moles, which is 0.01. Okay. So we have the mole. So to find mass, we just have to do molar mass times moles. And the molar mass is sodium carbonate. We have sodium carbonate here is Na2CO3, as shown over here. Na2CO3, which is two sodium, 1 carbon, and 3 oxygen. So Na, so 23 times 2 plus 12, and then 16 times 3. When you do it on the calculator, you get 3 times 2 plus 12 plus 16 times 3. We get 106. So we can do 106 multiplied by 0.01, which is the moles. We get 1.06. That's it. Okay. So this one. Okay. So first we need to balance. Balancing, pretty easy, this one. Okay. C is 1, H is 4, O is 2 on this side, and on this side C is 1, O is 2 plus 1, H is 2. Okay, we need to balance the hydrogen and the oxygen, so we can multiply this by 2 at first. So hydrogen becomes 4 on this side, and 2 plus 2, which is also 4. Now we balance the hydrogen, we need to balance the oxygen on this side, so we can do 2O2. So that makes it this one 4. So everything is balanced now. So this is the final equation. CH4 plus 2O2 gives you CO2 plus H2H2O. Yes, so we can fill in the values. 2, 1, 2, Y is 1. It's 1, it doesn't change. Okay, ratio by mole. Okay, here's ratio by mole as in the coefficient. So the coefficient of each. CH4, the coefficient is 1. O2, the coefficient is 2. No, CH4, the coefficient. No, wait, what? Okay, my bad. They put it in the bad order. H2O, the coefficient is 1, 2, 1, 2, is 1. And wait, what is this? Oh, they just, okay, the order is messed up. Okay. CH4 is 1, O2 is 2, CO2 is 1, and H2O is 1. That is the coefficient. H2O is 2. That is the coefficients of the values over here. Okay, Mr. Porter. Okay, ratio by mass. We need to find the mass, which is m is equal to moles times molar mass. Okay, we can do the molar mass, multiply them by the moles. We know all of them. So CH4, the molar mass is C, which is 12 plus 4 hydrogens, so 16. 16 times 1 is 16, and all 2, which is 32. 32 times 2, which is 64. CO2, 12 plus 32, 44, times 1 is 44, and H2O, 2H and 1O, that's 18 by 2, we get 36. That is the values. That are the values. Okay, yes, that is the value. Ratio by volume. Volume is just moles multiplied by the STP, which is 22.4. So that's basically going to be okay, so 1 times 22.4, like that 1 times 22.4, 2 times 22.4, basically the coefficient, the mole multiplied by the volume. So that is that. Now here it says negligible, write null or dash. Okay, so here they put dash here for the last one, which is liquid. Liquid, the volume is negligible for liquid. That's why we wrote it like that. Everything else here is gas. Liquid here is negligible. Okay, at STP, 2 moles of CH4 combined with how much volume of O2? Okay, so 2 moles of CH4. We can do MCR, most common ratio. Okay, CH4 is in the order of 1, and then O2 is 2. Okay, 1, 2. Okay, at STP, 2 moles of CH4 combined with, okay, we have the volume, which is 22.4. okay, so here it's going to be 44.8, but that is for 1 mole of CH4, which produces 2 moles of oxygen. They want 2 moles of CH4, which will give us 4 moles of oxygen. So that's going to be 44.8 on this side, and this one multiplied by 2, which is 89.6. Yes, most common ratio. And the last one is 20% oxygen. So at STP, 2 mole of CH4. Okay. 2 moles of CH4 combined with how much volume of air? Air is 20% oxygen. So you just 80. Yeah, you just multiply this by 5, because air is 20% oxygen. We have this is 20%. We multiply this by 5. That's it. 89.6 times 5 gives you 448. Yes, to make it 100%. Okay, last one. Oh, not last one, sorry. Okay, this one is limiting and excess. Okay, so first off, we have the I'm gonna read the question. Iron Fe burns to form a black solid, Fe3O4. Can a 5.6 gram piece of iron burn completely to form Fe3O4 in a vessel containing 1.12 decimeter cube of oxygen at STP conditions? So we can first off write the equation, which is Fe plus O2 gives us Fe3O4. Okay, but then this isn't balanced. Okay, so we can balance it by making the coefficient 3 here and 2 here. That makes all of it balanced. So we have the ratio 3 to 2 for iron and oxygen. Okay, what did they ask? They asked 1.12 volume of oxygen. Okay, to find originally how much of iron would completely burn to produce Fe3O4, that is what we're trying to find. Okay, how much iron would completely burn. So we need to find the moles of oxygen. So we have the volume here, divide that by the STP 22.4. So 1.12, that is to find the moles, by the way. 1.12 divided by 22.4, we get 0.05. Okay, 0.05 here. Doing MCR, we get multiplied by 3 divided by 2, we get the moles of iron to be 0.075. okay, that is how much would actually burn, like completely burn, to produce Fe3O4. okay, so what did they say? Can a 5.6 gram piece of iron burn? Okay, so now we know the original, how much it would actually take to completely burn. 0.075 moles of iron. Okay, now actually no. Okay, 5.6 gram. Okay, we know that N is equal to M over M. Now mass is 5.6. We're finding the moles of iron that they said according to 5.6 gram. 5.6 over the molar mass, which is Fe is 56, but we have 3 of them, so that's going to be, actually no, my bad, sorry, no need for 3, that's coefficient. Okay, so Fe is 56, so just 5.6 divided by 56, you get 0.1. Now 0.1 is greater than 0.075. So that is a limiting reagent, because we don't need the complete 0.1. We only need 0.075. We don't need the whole mole of it. That's why not all the iron will react. Only 0.07 mole. We don't need like 0.1. 0.25, we're not going to use them. Okay, that's why iron here is a limiting reagent. Okay, solution in which the solvent is water is called as an aqueous solution. Memorize that. Do not get the spelling mistake. Aqueous. Okay. This is okay. 2 liter of 10 m NaCl solution is prepared in a flask. 400 milliliter of the solution is poured out of the flask into a beaker. 400 milliliter into liter divided by 1000. So we get 0.4 liters. But we don't need calculation for this one, because they ask the concentration of the salt solution in the beaker. So if you pay attention to chemistry class, you will know that when you take something away from an order, like a mixture, a solution, like if you take one part of it and move it to another place, the concentration is not going to change. So 2 liter solution with 1 as the molar concentration, it's not going to decrease or increase if you change it into another beaker, because that it's a solution, it's already mixed, its concentration, it's not going to change. Okay, so it's going to stay the same. It's going to be 1 molar concentration, it's not changing. Okay, how many moles of NaOH are present in 400 milliliter of a 2 molar concentration NaOH solution? Okay, we have N is equal to Cv. C here is the concentration, which is 2. Volume being 400 milliliter, which is 0.4 liter, because we divide by 1000, so 0.4 multiply, we get the moles, which is 0.8. To 3 6 figure, 0.800. Okay, this is just balancing, but I balance it either way. So Na on this side is 2, C is 1, oxygen being 3. We have Na here. Oh wait, okay, I'll show you the version that isn't balanced. Okay, yeah. So, okay, Na here is going to be 1, C1O3. We just need to balance the Na, just 2. That's it, okay. Nothing special. Okay. So this one was explained in chemistry classes. Okay. So how to prepare 1 liter of one mole concentration of salt of a salt solution. So first off, we need to weigh the 58.5 gram of pure NaCl. Okay, that is the yes, that's the gram. Why is it 58.5? Because we want it to be 1 mole. Okay, so like 1 second. Yes, so like we have 1 mole. To find 1 mole, we have m over m, mass or molar mass. We know the molar mass of NaCl is 23 plus 35.5, which is 58.5. And to make it 1, as we multiply, we get 58.5 as well. So that is the mass of NaCl that forms 1 mole. Okay, that is the mass that we need to weigh 58.5 gram of pure NaCl. That is the first step. Second step, add the salt to about 250 milliliter of distilled water placed in a 1 liter volumetric flask and swirl the mixture until most of the salt is dissolved. Okay, why 250? Okay, I'll tell you why. So basically, let's say we have a beaker, okay? We place our salt, okay? This is salt. Yes, this is salt. Okay. Let's say first we fill up to this much water. This is 250, okay? This is 250. It doesn't necessarily have to be like 250. Okay, we're just saying we first fill in some water, okay? And then we stir it. We stir it until it dissolves, okay? And then again, like we fill water. That is what is said in the last step. Add more water to make exactly 1 liter of NaCl solution. So first at 250, you mix it, you stir them up to dissolve the solution. And then you keep adding the water all the way until you reach 1 liter. So 1 liter. Okay. It's just saying like as like first you put the salt and then you pour some water, not the whole thing. Like some water and then you stir it up until it dissolves and then you fill it up all the way to 1 liter. Okay, yeah, that's it. Like, and add more water to make exactly 1 liter because that's what we want. We want to prepare 1 liter. We don't want approximately 1 liter. No, we want 1 liter. So it's exactly. And yes, we need to use a volumetric flask for this one. Okay. Next question. Okay. The molar concentration of the solution is this is definition, so memorize. Molar concentration of a solution is the number of moles of solute per liter of solution. Okay, number of moles of solute per liter of solution. Just memorize. That's a rule. That's a definition. Okay, this is old stuff, but I'll do it either way. Okay, experiment 14.2 gram. We have the mass. We need to find the moles of chlorine reacted. Okay. Oh God. Okay. 14.2 gram. We have more. We have N is equal to M over M. 14.2 gram over molar mass, which is of chlorine 35.5, but then its chlorine is diatomic, so it's 70. So you get 0.2. Yes, you get 0.2. Okay, find the number of moles of sodium chloride produced. We do MCR. We get 1 to 2 sodium chloride produced. 1 to 2. So that's 0.2 cross multiply is 0.4. Okay. Find the mass of sodium chloride produced. We said that the moles of sodium chloride is 0.4. Just multiply that by the molar mass. Okay. Sodium chloride is NaCl. Yes, NaCl. So it's just 23 plus 35.5 for the molar mass. So 0.4 multiplied by 58.5. 58.5, you get 8.5, you get 23.4. Okay. Okay. Number of moles of oxygen gas. Okay, oxygen gas. We have 0.5 moles of butane gas. Okay, we do MCR. Okay, MCR. Okay, We have oxygen is, okay, we have butane 2, oxygen 13. Butane is 0.5, cross multiply, what do you get? 0.5 times 13 divided by 2, you get 3.25, yes. Okay, find the volume of oxygen gas needed to react completely with 0.5 mole. Basically just 3.25 multiplied by 24, which is RTP conditions. So 3.25 multiplied by 24, you get 78. And then air is 20% oxygen. Find the volume of air needed for the given sample of butane to react completely. So that's going to be 390 because air is 20% oxygen. We want the whole thing, so that's going to be 100% multiplied by 5, 78 by 5, we get 390. Okay, balancing. Okay, sample of 4.6. Okay, first off, balance. Na, they give Na is dipped into excess water, H2O, giving you aqueous solution of NaOH plus H2. Okay, Na on the side 1, H on the side 1, no sorry 2, O 1, Na 1, O 1, H 2 plus 1. Yeah, okay, we need to balance the hydrogen. Okay, we can just multiply this one at first by 2, so Na here becomes 2, O becomes 2, H becomes 2 plus 2, so that's 4. Okay, and here as well multiply by 2, the coefficient, so there it becomes, H becomes 4, and oxygen as well becomes 2, and that way we have hydrogen balanced and oxygen as well balanced, but sodium isn't balanced. Sodium is imbalanced, so we have to also make here the coefficient 2. So 2Na plus 2H2O gives us 2NaOH plus H2. That's it. Okay, find the number of moles of sodium metal reacted. Okay, sodium metal reacted, we have how much grams? 4.6, and 23 is the molar mass. Okay, so 4.6 over Na, which is 23, you get 0.2. yes. Find the number of moles of hydrogen gas released. So if the ratio is 2 to 1, 0.2, 0.1. Cross multiply, yeah, when you cross multiply you get 0.1. Okay. The steps used to separate the components of a mixture of sand and salt include the following. Okay, sand and salt. Okay, so first off we have to add excess water to the mixture and stir. Why? Because this way the salt will dissolve with the water, and that way it will be just like salt, water and sand. Okay, salt and water are like one now. Okay, and now we need to filter out the sand. So filter and allow the residue to dry. Residue is a sand, what remains is a residue. Okay, now we have the salt water. We need to separate the salt and the water. We just need the salt, so we have to heat the solution to crystallize. So the water leaves and then we have the salt, so we have them both separated. Okay, the liquid collected at the end of distillation is called distillate. Yes, that is like, yeah, that is distillate. The liquid at the end is distillate. Or the end of distillation is called distillate. Just memorize that. Okay. Choose the heavier gas. Like I said before, the one that is faster is the lighter gas, and the one that is heavier is the slower gas. So over here they say the rate of diffusion, and gas X has 0.63, which is faster than hydrogen chloride, which has 0.87. So hydrogen chloride is, oh wait, sorry, my bad. Gas X is faster because it is a much faster rate. 0.63, it took shorter than it took for hydrogen chloride. So gas X is faster, hydrogen chloride is more heavier, so it's slower. Molecular mass of gas X. Okay, now this one, how do we do it again? Yeah, okay, rate of diffusion. So rate of diffusion, I just write it R. Okay. Okay, R1 squared over R2 squared is equal to the molar mass. So molar mass of one over the molar mass of, sorry, it's always opposite. So molar mass of 2 over the molar mass of 1. Okay, so the rate of diffusion of the first one squared over the rate of diffusion of the second one squared is equal to the molar mass of the second one over the molar mass of the first one. So we can substitute the values. I'm gonna cross it out. Okay, 0.63 over 0.87 is equal to, we need to find the molar mass of hydrogen chloride, which is HCl, 35.5 plus 1, so that's 36.5 over m1. Yeah, okay, we can simply do like, oh, square by the way, so we can do 0.63 squared. Okay, we have that. We need to cross multiply on both sides, so 0.87 squared multiplied by 36.5 gives you 27 point, you get an odd number. Okay, 27.6, divide that by the square of 0.63, so you get 69.6, 69.6 and on. Okay, that is the molecular mass, the molar mass of the gas X. Drag and drop the following to arrange them in increasing order of rate of diffusion. So the higher the molar mass, the slower. So like the heavier, the slower it is. Okay, so we have HCl is 36.5. We need to find CO2. CO2 is 12 plus 32, so we get 44, which is heavy, and H2O, which is hydrogen is 1, there's 2 hydrogens, so 2 plus 16 we get 18, so 44, and then HCl, as said before, is 36.5, and then H2O will be 18. So it's from heavier to lighter, which is slower to faster, increasing order of rate of diffusion. Okay, two gases A and B are injected into opposite ends of a glass tube. When the two gases collide, they react, forming a colored stain on the inside walls of the tube. A schematic diagram of the experiment is given below. Choose the phenomenon responsible for the two separate gases to collide with each other and react. Okay, diffusion. So when gases collide with each other and react, is diffusion. Okay, effusion is when they get out of small holes. Okay, that is effusion. The diffusion is when they collide and react. Okay, choose a lighter gas. Okay, here gas A, okay, gas A and gas B. Okay, gas A, this is the midpoint as shown here. This is the midpoint. Okay, the orange tube. So gas A is reached this part, the colored stain, faster than it did for gas B. So here it reached much faster than it did for gas B. Okay, when both of them, this was the point at which both of them collide. Okay, and this one reached a further distance. Gas A reached a further distance than gas B did. Okay, so gas A went more faster, so it was able to cover more distance than gas B did, and then they collided at orange part. So gas A is the much faster one because it reached a much more distance. It reached a further distance. Okay, now in an exothermic reaction, energy is released. Okay, Yes, that is exothermic is release of energy. Therefore, the temperature of the reaction mixture increases. So when an exothermic reaction occurs, energy is released, temperature increases. In an endothermic reaction, energy is absorbed, like breaking down something, okay? Burning a piece of wood. Burning a piece of wood. When we burn, we are releasing energy, we are releasing heat. Okay, so that is exothermic, okay? We are not breaking something, we are burning. We are burning. When water solidifies to ice. When water solidifies to ice, it's like when water gains, when water is cooled. And when it's cooled, it's going to release energy. It's exothermic. Okay, it's not absorbing energy. Then it's not going to become ice. Dissolving sodium hydroxide in water, which makes a solution warmer. It makes a solution warmer. What do we say? Exothermic reaction. The temperature of the reaction mixture increases. So when the solution is warmer, it's exothermic. Melting of wax. We are melting the wax. We are absorbing heat and turning a substance into wax. We are like for example, candle. We are turning it into wax. We are we are melting it. We are breaking it down. So it's endothermic because we need the heat. Okay, that's it for this quiz. Hope you guys understood everything. If there's anything you guys are not sure of, please don't hesitate to ask. Thank you for watching and have a good exam. Bye.